Hey, I'm Taylor Aldridge. This is my RC car circuit board. It's a pretty simple design for DC motors, 2 servo motors, and 3 locators, all controlled by an Arduino board using a 9-volt battery to power the DC motors. We can start the simulation, see that these are running forward, these move into the forwards position, and that it is moving forwards. We are currently set up to go to the right. If we move this out, it calls the steer correct and it moves back to a position to where it will move back in the range. If we go under the range, it'll turn the other direction. The same thing will happen on the left side if we set it up for the left, just in the opposite directions. If we look here at the code, we can see we have a whole lot of code here to set up the servo locate. We set up the servo motors, we set up pin variables. For everything, we set up an is moving variable, Boolean value to stop and put out the time when we move. Info for the calculations. Wall length is our final length of the wall based on how long it's traveling. Is aligned left. This is where we would change left or right echolocator. And we have some wall distance and front distance for the echolocator calculations. And we have a left locate, right locate, and front locate functions. That basically just run the echolocators and return a value for how far away they are. We have a move forward, which will set the servo motors to the correct forward position, and then we move the forward motors forward at full speed. And then we have the steer correct function for determining which way to turn and turning to move it back within the correct range. Calculate distance and stop functions work together. The stop is called when the front locate is under 5 inches away. We can see that here, and then it will stop the motors, give us an end time, tell us the end time in milliseconds, and then call the calc distance, which will then take this and using some math, we'll calculate this all based on the distances called. Setup is pin modes, attaching our servo motors to their pins and starting to move and give us our starting time in milliseconds. And then it will print our start time. We delay by 10 milliseconds in order to basically help the browser sim keep up a little bit. Not great. Then we set all of our echolocators to low, and then we determine based on if it's left or right aligned, which locate to call. We set our be moving to true if we are outside of the 5 distance and we're not there already, so we can restart pretty simply. In a future revision, this would be done via button to tell it to do that, and then to perform this check. Then we calculate the wall distance where we are, call move forward if we are within spec. If not, then we will call the steer correct, which will then determine based on the wall distance which way to turn. If this is less, it's the same thing as this, just 2 different things. And then finally, if this we set we are moving and we're less than or equal to 5 inches, we stop moving using the front distance so we can add that into our calculation, and we set moving to false so that it won't continue to print everything. We can come back up here too in our code to find the calc. It takes the distance from the front into the stop, does all this, calls it using that distance. Using float, we have the time, which is the end time minus the start time divided by 60,000. That gives us the time in minutes. Then we can print out that total time. Wall length is time plus distance per minute, which is calculated, hard-coded to be based on the circumference of the wheel times the RPMs. And then we add in the distance that we are away from the wall based on the echolocator. And that gives us our final wall length, which is then printed. In a future revision, this would be transmitted all wirely. However, we were using the serial out to simulate that. Thank you.